The Eaton company sells fragile vessels through mail orders but faces issues with fresh damage, which can lead to customer dissatisfaction and lost future orders. To address this, the company uses two packaging materials from different suppliers, assuming both are equally effective. The seller's manager recently decided to study this assumption.
For question A, a hypothesis test is carried out at 0.05 significance level. The population variance of material 1 and material 2 are assumed equal. Since their sample sizes do not exceed 30, T-distribution is used to construct the critical region for rejection of the null hypothesis. After finding the poor estimate of the variance, the statistical test is computed. Since the value obtained is outside the critical region, the null hypothesis does not be rejected. For question B, since the null hypothesis is accepted, the type of error could happen is type 2 error, which means the null hypothesis is false but still be accepted. This error indicates there is difference between the damaged shipments of material 1 and material 2. If this error occurs, the cost of the shipment of vases will increase as the number of damaged shipments increases. The sales rate of the vases also decreases due to this situation.
For question C, we first calculate the values for material 1 and material 2 using the calculator. Next, we use the Z distribution since N1 and N2 are less than 30, and the population variances for material 1 and material 2 are known to be 6 and 5 respectively. We then set up the hypothesis. The null hypothesis, which is the mean for material 1, is equal to the mean for material 2. And the alternative hypothesis, which is the mean for material 1, is different from the mean for material 2. Since the significance level is equal to 0.01, we will reject H0 if the absolute value of Z is greater than Z sub alpha over 2, which is equal to Z 0.005, which is equal to 2.5758. After calculating, we find that Z is equal to minus 0.3857. Since the Z value is greater than minus 2.5758, we will fail to reject the H0. Therefore, there is sufficient evidence to support that the claim that there is no significant difference in the proportion of damaged shipment resulting from the use of either packaging material at the 0.01 significance level.
For question D, we can calculate the sample size, sample mean, and sample standard deviation for material 1 and material 2 by using calculator. Based on the information, we know that N1 and N2 are both less than 30, and the variance 1 and 2 are unknown. Therefore, we use T-distribution for analysis. Given the confidence interval is 95%, so the alpha is 0.05. For statistic table, we get the value critical T value is 2.201. Next, use the formula of V to find the degree of freedom V is equal to 40. At the last, we use the following formula to calculate the confidence interval for the mean difference and get the final answer, which is confidence interval for the mean is between negative 1.709 and 1.1506.
For question E, the problem involves determining if the variance of number of damaged parcels using packaging material 1 is more than using packaging material 2 at the 0.05 level of significance. Based on the data provided, we obtain that N1 equals to 23 and N2 equals to 19. Then we use the data given to find the sample variance for both materials. From the question given, we can notice that alpha equals to 0.05 and H1 is variance 1 greater than variance 2. Hence, we know that H0 is variance 1 less than or equals to variance 2. Based on the information, we determine that one tilde test, which is right tilde test, is appropriate for the situation given in the question E. Next, we construct the critical region based on alpha. By applying the formula of degree of freedom V equals to n minus 1. Then we create a F distribution table by using Excel to find the critical region. Then we compute the test statistic by using the formula F equals to variance 1 over variance 2. After that, we reach a decision. Reject #0 if the compute test statistic is in the critical region, otherwise do not reject #0. Last, we draw scientific or engineering conclusion whether the variance of the number of damaged parcels using packaging material 1 is more than using packaging material 2 at the 0.05 level of significance.
For question F, the objective is to calculate the maximum error when using the sample mean 4.8261 as a point estimate of the true population mean for the number of damaged parcels with 95% of confidence level. From the sample data of packaging material 1 provided in the question, we know that the sample size is 23. Since the sample size is less than 30 and population standard deviation is unknown, therefore we use this formula of error to calculate. According to the formula of error, we need to find the sample standard deviation. We use this formula for the sample standard deviation and hence we get a value equal to 129.3043. Since 95% confidence level is chosen, alpha is equal to 0.05. Therefore, the critical value 2.074 is determined based on the degree of freedom 22 from the t-distribution table. By applying the formula of error, we substitute the value of critical value, sample standard deviation, and sample size into the formula. Hence, we get a value for the maximum error which is 1.04845. Thus, with 95% confidence, the maximum error when using the sample mean 4.8261 as a point estimate of the true population mean for the number of damaged parcels using packaging material 1 is approximately 1.04845. This indicates that the true population mean is likely to fall between 3.77765 and 5.87455.
In question A, a hypothesis test is computed to find out whether the difference between the damaged shipments of material 1 and material 2 is equal to 0 or not. The conclusion is there is no difference between the damaged shipments and the null hypothesis is accepted. To improve the accuracy and consistency of the information collected, the sales manager could increase the significance level or increase the sample sizes of material 1 and material 2, so the slight difference between them could be detected. In question B, since the null hypothesis is accepted, the type 2 error may occur. In this situation, the cost for the shipment of vessels will increase and affect the sales of the vessels. To avoid this situation happens, the increase in sample sizes or significance level is recommended. Increase in sample sizes ensure the information is closer to the real situation in the market. Increase in significance level strengthens the statistical power and reduce the risk of getting the type 2 error.
For question C, the objective is to determine whether there is a significant difference in the proportion of damaged shipments resulting from the use of two different packaging materials. A two-tilde test was conducted at a significance level of 0.01 as both sample sizes are less than 30 and the population variances for both materials are known. Based on the data, the calculated test statistic was Z is equal to minus 0.3857, which is much greater than the critical value of Z, which is minus 2.5758. As a result, the null hypothesis was not rejected. This leads to the conclusion that there is sufficient evidence to support that the claim that there is no significant difference in the proportion of damaged shipments between the two packaging materials at the 0.01 significance level. To increase the confidence in these findings, it is recommended to either increase the sample size or conduct a further test.
The discussion for question D is the given question determine the 95% confidence interval for the mean between in the number of damaged parcels between material 1 and material 2, assuming normal distribution with unequal variance. Applying the t-distribution for unequal variance using the well-settled Wave formula to estimate the degree of freedom. The critical value is when was obtained from the t-distribution table for the given confidence level. The results show a confidence interval is between -1.7 and 1.156 since the interval includes 0. It suggests no significant difference in the mean number of damaged parcels between the two packet materials at the 95% confidence interval. To improve the analysis, larger sample size could be collected to reduce the variability and increase the precision of the confidence interval.
For question E, the question aims to determine if the variance of number of damaged parcels using packaging material 1 is more than using material 2 at the 0.05 level of significance. Based on the sample data, the F-test statistic F equals to 1.2626 was calculated, which is less than the critical value F equals to 2.168. As a result, we fail to reject the null hypothesis, concluding that there is insufficient evidence to support the claim that the variance of number of damaged parcels using packaging material 1 is more than using material 2 at the 0.05 level of significance. Increasing the sample size or conducting addition tests with other material may yield more robust results.
The question aims to estimate the maximum error when using the sample mean 4.8261 as a point estimate of the true population mean of the number of damaged parcels using packaging material 1. Based on the sample data and a 95% of confidence level, the value of maximum error is approximately 1.04845. This indicates that the true mean will likely fall between 3.77765 and 5.87455. The confidence interval gives an idea of the fluctuation in the number of parcels damaged. A relatively narrow range indicates that the sample data is good for estimating the true population mean. However, this result is dependent on the assumption that the sample is representative of the population. The population is normally distributed and the sample size 23 is sufficient to justify the use of the t-distribution. To obtain a more precise result, we may increase the sample size. In short, this analysis shows the importance of monitoring packaging quality to reduce damage rates and maintain customer satisfaction.